In this video, we'll continue practicing with buffers. For each weak acid, write the conjugate base and a salt of the conjugate base. So here's the weak acid, sulfurous acid. Because it's a weak acid, it will lose or donate a proton, leaving us with this, HSO3 minus. This is the conjugate base. So now let's pick a salt of the conjugate base. You can pick any metal you'd like. I chose potassium. So this is KHSO3. This is the weak acid. This is the conjugate base. This is the salt of the conjugate base. Let's do one more. You should recognize this by now as acetic acid or vinegar. It's a weak acid and it donates a proton. So this is the conjugate base. So now just replace the H with a metal and that will be the salt of its conjugate base. So we could have something like this, sodium acetate. Or if you're more comfortable writing the metal first, you can do that too. Either way is fine. Are the following solutions buffers? Now remember what makes up a buffer. It has to be a weak acid and the salt of its conjugate base. We need both of those things, a weak acid and the salt of its conjugate base. If we don't have those two things, it's not a buffer. So, is this pair here, is that a buffer solution? I would say no, because HCl is a strong acid. It needs to be a weak acid in order to be a buffer. What about this pair? Does this make up a buffer solution? Yes, I think it does. Hydrofluoric acid is a weak acid, and this would be a salt of its conjugate base. What about this? This is hydrocyanic acid. What do you think? Well, I think this also would be a buffer solution. This is the weak acid, and this is the salt of its conjugate base. Let's try one more. What do you think about this pair? Does this pair make up a buffer solution? I would say the answer is no. This is nitrous acid. This is a weak acid, but it has to be paired with the salt of its conjugate base, and it's not. It's paired with nitric acid, which is a strong acid. So a weak acid and a strong acid does not make up a buffer.